Okay, so this is the end of the fourth week. We only have 2 more weeks of class remaining. And now that we looked at limits, we're in a position to start looking at a little bit of calculus. And so today what I want to do is introduce the idea of a tangent line, the slope of a tangent line, and the derivative of a function. Okay, so let's suppose we have some function f of x. So f of x is a given function. And we'll suppose that it has a graph that looks something like this, all right? And here we have a point with an x-coordinate, x sub naught. I'll call this point here P, and it has the coordinates x sub naught, f of x sub naught. Here's my x-axis. This is my y-axis. And we know that y is equal to f of x. And here's our point P on the curve, okay? And suppose I take another point out here. This is going to be a point Q. And the x-coordinate of the point Q I'm going to write as x sub naught plus h. So the way I have this drawn, h is some positive number. So I have the distance between these 2 points is h. So that's the distance between P and Q. Okay? Now we know the 2 points determine a line, and so I'm going to draw a line here. And let me change the color. So we'll draw this line. All right. Then what can you tell me about the slope of the line PQ? So I'm going to call this line. We'll call this line PQ. Okay. And so what I'm asking for is the slope of the line PQ. Well, you'll remember that slope is equal to the rise over the run. That's how a lot of people think of it, or delta y over delta x. So let's compute this value. Let's compute this value, delta y over delta x, for this line PQ. So this is going to equal, well, what are the coordinates of the point Q? We know the x-coordinate of the point Q is x sub naught plus h, and the y-coordinate is going to be what? Well, it's just the value of the function f evaluated at x sub naught plus h. Okay? So we're looking at delta y. So delta y is going to be f of x sub naught plus h, the y-coordinate of the point Q, minus the y-coordinate of the point P, which is f of x sub naught. And then delta x is going to be the x-coordinate of the point Q minus the x-coordinate of the point P. So that's going to be x sub naught plus h minus x sub naught. Right? Now what I'm going to do is this. So here's where what we've studied about limits comes into play. What I'm going to do is I'm going to let this h become smaller and smaller. So I'm going to let h actually approach 0. So I'm going to let h approach 0. So what does that mean about the point Q? So as h approaches 0, this point Q is going to do what? It's going to slide along this curve and the point Q is going to approach the point P. So as H goes to 0, the point Q approaches the point P. All right. Well, so suppose for some value of H, Q is here at this point, and then I'm looking at this line here. All right. These lines, by the way, these lines are called secant lines. Yep. Yeah, there we go. So these are called secant lines. And as the point Q approaches the point P, if this limit exists, so I'm going to look at the limit now. So what I'm going to do is I'm going to look at the limit of the slopes of the line PQ as H goes to 0. So I'm going to look at the limit as H goes to 0 of these slopes, f of x sub naught plus h minus f of x sub naught divided by, well, it's divided by x sub naught plus h minus x sub naught, which is just h. Okay? Now, if this limit exists, we say that the secant lines approach a tangent line at the point P, and the point P has the coordinates x sub naught, f of x sub naught, whose slope is given by this limit. All right, so let's go back to our picture up here. And now what's happening as this point Q, as this point Q gets closer and closer to the point P, the slope of these secant lines determined by the point P and Q, they're tending, those slopes are getting closer and closer to some number, which we call the slope of the tangent line to the function f of x at the point P. And so let me draw that. It's going to look like this. It's going to be a line that kind of looks like that. And actually what we could do is, let's make another drawing to help us see what's going on. So again, here I have a curve. I'll make it like that. This is the graph of some function f of x. Here I have a point P, and it has the coordinates f of x, x sub naught, comma, f of x sub naught. And then I'm going to look at a point out here. This is Q. And the x-coordinate of the point Q is x sub naught plus h. And the y-coordinate is just f of x sub naught plus h. This is x sub naught down there. And I have this line. So I have a line determined by these 2 points. And this line is the secant line PQ. All right? Now, I'm going to look at the slope of that secant line. So the slope of the secant line, PQ, is equal to f of x sub naught plus h minus f of x sub naught divided by h. All right? Now, what we're interested in doing is we're interested in letting h go to 0. So we're going to let h go to 0. So as h gets smaller and smaller, the x-coordinate of the point Q gets closer and closer to x sub naught, which means that this point Q is moving along the curve and getting closer and closer to this point P that remains fixed. So as h approaches 0, the point Q approaches the point P. All right, so as it does, I'm going to draw another line here. As it does, we get a family of secant lines. We'd have a family of secant lines that would look something like this. And now, if the limit of the slopes of the secant lines approaches a fixed number, some number, then that number represents the slope of a line which we say is tangent to the curve, which is the graph of the function f of x at the point P. And that tangent line would be represented by this green line. So let's write that down. So if the limit as h goes to 0 of f of x sub naught plus h minus f of x sub naught, all divided by h, exists, so it means that it approaches some number, then we say that the tangent to the graph of f of x at the point P exists and has slope given by, has slope given by this limit. The limit as h goes to 0 of f of x sub naught plus h minus f of x sub naught, all divided by h. Okay, so let's look at an example. So we'll take it as our function f of x. Let's take, let's just make it x squared. Okay, so it's the function of x squared, whose graph we know is a parabola. So the graph of this function is kind of like this. Parabola symmetric about the y-axis. And let's take a point here. Let's take the point 2, 4. And this will be our point P. Now what I want to do, I want to find, so here's my problem. I want to find the tangent line to the graph of f of x equal to x squared at the point P, whose coordinates are given by 2, 4. Right? So that tangent line is going to be a line that we think of as just kissing the curve, the graph of the function f of x at this point P. It would be the limit of the secant lines that we drew, those secant lines PQ, where we have some point Q on the graph of f of x, which gets closer and closer to the point P, and as it does, these secant lines move closer and closer to the tangent line. So they get closer and closer to the tangent line as the point Q gets closer and closer to the point P, provided the limit of the slopes of the secant lines exists. So we have to look at, so what we want to do is we want to look at the limit as h goes to 0 of the slopes of those secant lines. So this is going to be f of x sub naught plus h minus f of x sub naught divided by h, where in this case x sub naught is equal to 2. That's the x coordinate of the point P, and f of x is equal to x squared. So this limit that we want to look at, this limit here, is equal to, in this particular example, it's going to be the limit as h goes to 0 of 2 plus h squared minus 2 squared divided by h. And if I expand this out, this is the limit as h goes to 0 of 4 plus 2h plus h squared minus 4 divided by h, which is equal to the limit as h goes to 0. The 4's cancel, and I can pull out a factor of h. So I can write this as h times 2 plus h, all divided by h, which is equal to the limit as h goes to 0 of 2 plus h. Okay, and this is not 2. So let me make a correction here. I did a mistake when I multiplied. So that mistake, let me bring back my pen. That mistake, oops, why is my pen, there we go. That mistake, I should have a 4 here. And here I have a 4. And here I have a 4. Okay, so now we're looking at this limit, and as h goes to 0, this quantity 4 plus h is just going to approach 4. All right, so this tells me, since this limit exists, so this limit exists, this tells me the slope of the tangent line that we're looking for. So the tangent line to the graph of f of x equal x squared at the point 2, 4 is equal to 4. All right, so I want the equation of the tangent line. So we know that this tangent line has a slope equal to 4, and it passes through the point through the point 2, 4. So the equation of the tangent line is given by y minus 4 is equal to 4 times x minus 2. Right. So this is going to be what? This is y is equal to 4x minus 8 plus 4, so plus 4. There we have it. This should be a minus. Oops. Let me correct that. This should be a minus 4. This is minus 8 plus 4. Okay, so this is the equation of our tangent line. Let's try another example. Let's look at the function f of x equal to 1 over x plus 2. All right, so a rational function. So we want to look at, we're going to look for the tangent line to this function at the point x equal, let's make it x equal, I don't know, 2 also, right? Now, so we look at a tangent line at a point on the curve. And what we're asked for here is we're asked to look at that point on the curve whose x coordinate happens to be 2. Well, we have to know the point exactly. We need to know the coordinates of the point. And so we know that the coordinates of that point, which we're calling P, the x coordinate is going to be 2, the y coordinate is going to be f of 2, and in this case, that means that this point is going to be 2, comma, f of 2 is going to be 1 over 4. Right? Okay, so what do we know? We have to look at the limit as h approaches 0 of f of x sub naught plus h minus f of x sub naught divided by h, where in this case, f of x is equal to 1 over x plus 2, and x sub naught is equal to 2. All right? Now, if this limit exists, then our tangent line is going to exist, and the slope of that tangent line is going to be this limit. So everything hinges on the existence of this limit and our ability to find that limit. So let's see what we can do. So we're going to look at the following. The limit as h goes to 0 of f of x sub naught plus h. Well, x sub naught is 2, so I'm going to write this 2 plus h minus f of 2 divided by h. And this is equal to the limit as h goes to 0 of f of 2 plus h. Well, we know that f of x is equal to 1 over x plus 2. So f of 2 plus h is just going to be 2 plus h plus 2 minus f of 2, and f of 2 is just going to be 1 over 4, all divided by h. Okay, so this is our limit that we have to evaluate. And notice, if I just look at the limit of the numerator divided by the limit of the denominator, what do I get? I get 1/4 minus 1/4. That gives me 0 in the numerator. and then my denominator is going to 0. So I have this expression 0 divided by 0, which we know is meaningless. It has no meaning. So we can't do anything with that expression. So in order to evaluate this limit here, I'm going to have to try to express this quantity inside the parentheses in a different form. And how can I do that? Well, in my numerator, I have two fractions. And what I'm going to do is I'm going to add those together. So I'm going to write this as the limit as h goes to 0. Now I need a common denominator, and that common denominator is going to be 4 times 4 plus h. So over here I have 4 plus h. And then what do I have? I have, up here I'm going to have 4 minus 4 plus h. So that's my numerator, and that's being divided by h. And this should not be a minus sign here. It kind of looks like a minus sign. That was just a typo. All right, so this is equal to the limit as h goes to 0 of, okay, look at this numerator. This is 4 minus 4 plus h. That's going to give me minus h divided by 4 times 4 plus h, and this h I can bring up here. Okay. And now this is equal to the limit as h goes to 0 of minus 1 divided by 4 times 4 plus h. And now what happens to this? As h goes to 0, this quantity here goes to 4, so my limit is going to go to minus 1 over 16. So this limit exists and is equal to minus 1 over 16. So this is going to be the slope of the tangent line. So the slope of the tangent line to the graph of f of x equal 1 over x plus 2 at the point 2 comma 1 over 4 is minus 1 over 16. And so this tells me the equation of the tangent line is, well, it's going to be y minus the y coordinate of a point, of the point that we know is on the tangent line, the point P, so this is 1 over 4, and that's equal to the slope of our tangent line, minus 1 over 16, times x minus the x coordinate of the point P, which we know is a point on the tangent line. And there we have it. So I could simplify this and write this as y is equal to minus 1 over 16 times x plus 1 over 8 plus 1 over 4. And so this is equal to minus 1 over 16 times x plus 3 over 8. Okay. So this is our equation of the tangent line. Okay, so try a few suggested problems, and we'll say a little bit more about these limits and a concept called a derivative.